vector. Suppose if you have a physical quantity, I defined you in second chapter, physical quantity means the quantity which we can measure. So you'll say all measurable quantity are termed as physical quantity. Now we may divide this measurable term into two parts. Let's say first is x be any physical quantity which having some numerical value and some specified unit for the measurement of that part. So x is any physical quantity, n is numerical value, and u is specified unit. Is it clear?
Yes, sir.
Okay. Now this numerical value and specified unit in combination will define you nothing but magnitude of that particular given quantity. Similarly, we may define another term. Let's say y is equals to numerical value, unit, and some theta to define its direction. So in this part, this is numerical value, this is some specified unit. So these two terms will define you nothing but magnitude. This theta is angle, which will define you nothing but direction. Shab, is it clear till this part? Okay. So from this, you'll conclude x is a quantity which having only magnitude. So this will be termed as scalar. And y is another quantity which having both magnitude as well as direction. So we called it as vector. Is it clear to this part? What do you mean by scalar and vector?
Yes, sir.
Okay, just write it down.
Done, sir.
Wahid, have you done? Okay. Next is representation of vector. How we represent any vector? So we can represent a vector in two different ways. First is called analytical way and second is called Cartesian form. First is analytical method, in which A vector is represented by any arrow, let's say from this point to this point. In this representation, the length of arrow from this point to this point will define you nothing but its magnitude. Similarly, this part, that is arrowhead, will define you nothing but direction. So we can say this arrow representation having both magnitude as well as direction. So this is called analytical way of representing any vector. Okay. There is another way of representing this particular term, which is called Cartesian form. So next is Cartesian form. In this term, we first define what do you mean by unit vector. As its name is suggesting about unit, which means a vector which having unit magnitude or magnitude 1 and which shows only direction is termed as unit vector. So you will say a vector having unit magnitude and shows direction only is termed as unit vector. Is it clear till this part?
Yes, sir.
Okay, just write it down. Have you done? Now, in this unit vector, we may divide two parts. One is called universal unit vector or unit vector along coordinate axes. Unit vector along coordinate axes. Let's say we have three coordinate axes, x, y, and z. x-axis, y-axis, and z-axis. So to define direction along x-axis, we use I cap. Similarly, along y-axis, it will be j cap, and along z-axis, it will be k cap. So cap is a representation of any unit vector. So to define direction along x-axis, it will be I cap. Along y-axis, it will be j cap, and along z-axis, it will be k cap. There is another that is called unit vector along any vector itself. Let's say A is any vector. So we have to define unit vector along this. So it will be A cap, and it will be vector divided by its magnitude. So this A cap is nothing but unit vector. A having arrow notation is termed as a vector, and A having mod over it is termed as magnitude of that particular vector. Is it clear?
Yes, sir.
Wahid, any doubt till this? Okay, just write it down.
Done, sir.
Wahid, done? So I'm defining you. What do you mean by vector? So let's say you have a point A having coordinate x and y. It means this x will have component along x-axis as x. Similarly, it having a component along y-axis as y. So if you join from this part to this part, it will represent any vector. So from this, we'll conclude A in terms of vector can be written as a vector having two parts, or a vector will have two parts, one magnitude and the other is direction. Let's say this particular A, which having magnitude along x-axis, so it will be just x. Now, how will you define this particular magnitude is along x-axis? So for that, we have to multiply it by its direction so that it will define only along x-axis. So it will be I cap. Similarly, this particular vector having magnitude y along y-axis, so it will be y. And then how will you define this is along y-axis? So just multiply it by j cap. This is how we convert any coordinate system into any vector representation. Is it clear?
Yes, sir.
Now, since this arrow originating from this point to this point will define you nothing but its magnitude. And now just in this particular triangle, we have base as x and perpendicular as y. So using Pythagoras theorem, if you want to calculate length of this arrow, which will define you nothing but its magnitude, so it will be termed as a mod is equals to root under base square plus perpendicular square. So this is vector and this is magnitude of that particular vector. Is it clear?
Yes, sir.
Shab, any doubt? Okay. Now, if you define or if you want to calculate unit vector along A itself, so for unit vector, just divide these two terms. Similarly, if you want to calculate A cap, it will be vector divided by its magnitude. So it will be x times I cap, y times j cap divided by its magnitude, that is x squared plus y squared. Now the next term is to define its inclination with respect to x-axis. Let's say this having inclination theta with respect to x-axis, which will define you its direction. So for this theta, we have perpendicular as y and base as x. So if you take tan theta, so it will be perpendicular over base. From this, you will define theta of this vector with respect to x-axis. So from any coordinate system, we may define these 4 different parameters related to that. Is it clear, Mamuna?
Yes, sir.
Okay, just write it down. I'm giving you some example related to this.
Done, sir.
Go ahead, done. I'm giving you one problem related to this. If P is at 1 comma root 3, find first P vector, second magnitude of it, third theta. Try to solve using the above concept. Just put all the values in this above expression. You will get all these. Good, Mamona. Shab, any doubt? Just see how to define it. Let's say P having coordinate 1 and √3. So P in vector is equals to magnitude of this along x-axis times I cap. So it should be 1 times I cap plus along y-axis. So it will be √3 times j cap. Is it clear? Share. Okay. Similarly, if you want to calculate its magnitude, so P mod is equals to root under x component square. So it will be 1 square plus y component square. So it will be √3 square. So 1 plus 3 root under, which will be 4, and on taking square root, it will be just 2. Similarly, if you want to calculate inclination, that is tan theta, so it should be perpendicular over base. Perpendicular, that is y, √3 divided by base is 1. So it will be just √3. So tan theta is equals to √3 So theta will be equals to 60 degree. Wahid, is it clear to this part? Do you have any doubt till this? So this is all about representation of vector, how we represent any vector and define magnitude and so on. I'm giving you one more problem related to this. Let's say A cap is equals to 0.6 I cap, 0.4 J cap plus lambda K cap. Find lambda in this. So how to define it? Just say in this particular expression, here we have A cap. It means A is nothing but a unit vector. And I had defined you earlier, a unit vector is nothing but a vector having unit magnitude or which having magnitude as 1. So you'll say mod of unit vector will be 1 and it should be equals to root under x square, that is 0.6, y square, that is 0.4, and z square, that is lambda. Is it clear, Amona?
Yes, sir. Yes.
Okay. Just take squaring both sides and simplify it to get lambda. Try to solve. So you'll say on squaring both sides, it will be 1 is equals to 0.6 on squaring will become 0.36. 0.4 on squaring will become 0.16 lambda square. So move these two terms to the other side. It will be 1 minus 0.36 plus 0.16 will be 0.52 is equals to lambda square. So if you subtract these two terms, you will get 0.48 lambda squared. And since you have to calculate lambda, move this square to the other side, you will get lambda is equals to root under 0.48. Is it clear?
Yes, sir.
Shab, any doubt? Okay. Are we done?
Yes, sir.
Next is some property related to a vector. Let's say a vector along this direction, let's say vector A. If it is slide along this direction or along this direction, or slightly displaced along this direction or along this direction. If length of this particular arrow is fixed and its inclination with respect to x-axis is also fixed, then you may slide this particular vector in any of these four terms. It will be remain same. Okay. So there is no impact of sliding a vector if its length and orientation or inclination with respect to x is fixed. A vector may be slide along any direction keeping its length and inclination remains same. Is it clear?
Yes, sir.
Now from this, we can define what would be the limiting condition for equality of two vectors. So you will say a vector having just two parts, one is called magnitude and the second one is called direction. So if magnitude of first vector equals to magnitude of second vector and direction of first vector is along direction of second vector. Direction is represented by unit vector. So if these two terms are equal, so we can say the two vectors are equal. So for equality of two vectors, there must be same magnitude and they must be along same direction as well. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Sure, done. Now next is operation on vector. So we have two different way of operating any vector. First is, let's say, addition. Let A is equals to AX I cap, AY J cap, and AZ K cap. Similarly, another vector B, which having magnitude Bx I cap, By J cap, and Bz K cap. So if you want to add these two terms, A plus B, according to the principle of homogeneity, same term or like term will be added together. So in this part, I will say component of same term will be added or subtracted. Let's say in first vector A, we have Ax as I component or X component. Similarly in vector B, we have Bx as X component. So on adding, Ax and Bx will combine together. Similarly, Ay, By, and similarly Az plus Bz. Is it clear?
Yes, sir.
There is one another way of adding any two vector, which is called analytical way. In this, we define three different methods. One is called triangle law. Let's say if you have a vector along this direction and another along this direction. A vector may be slide along any direction if its length and orientation keeping fixed. So if you move this vector B along horizontal direction so that the tail of this coincides on head of first vector like this. Let's say A is along this direction and B is along this direction. So if two vectors are arranged in such manner are termed as consecutive vector, which means the tail of second vector lying on head of first vector. Is it clear?
Yes, sir.
So the resultant of these two terms will join from tail of first vector to the head of final vector like this. So this will be your resultant of A and B. So this is called triangle law, which means put the tail of second vector to the head of first. This will be termed as consecutive vector. Then the resultant will join from tail of first to the head of second. Sure, is it clear? Then you will say a resultant is equals to A plus B, or this is termed as triangle law. Just write it down.
Done, sir.
Sure, done. Any doubt till this part? Okay. Next is parallelogram law. In this part, we have to somehow arrange any two vector as co-initial vector or co-terminal vector. Let's say first vector is along this direction, A. Move the second vector along this path, so it will be B. Now these two vectors having same initial point or starting point, so this will be termed as co-initial. So you will say two vector having same initial point or starting point is termed as co-initial vector. Two vector having same initial or starting point is termed as co-initial vector. Similarly, you may draw A parallel to it like this, and similarly B parallel to it like this. Now check in this part, we have two vectors having same final point. So it will be termed as co-terminal vector. So you will say two vector having same final point is termed as co-terminal vector. Is it clear?
Yes, sir.
Now, the resultant of this particular representation will be diagonal in between them, like this. So this will be resultant. So in parallelogram law, state arrange two vector as co-initial or coterminal, then it will form parallelogram. So diagonal in between them will be resultant. So R is equals to A plus B. Shab, is it clear? Okay, just write it down. Mamuna done?
Yes, sir.
Shab? Okay. Next is Polygon Law. It is for more than two vector. So let's say this is first vector A. Put the tail of second vector on head of it like this. Similarly, put the head of next vector on head of it like this. Similarly, like this, and so on. Then, on arranging all these vectors, a vector starting from first to last will be termed as resultant. Or we may define this particular resultant in some other way as well. Let's say, if you join from this point to this point, we call it as R1. So R1 will be equals to A plus B using triangle law. So you will say R1 is equals to A plus B. Now, if you again draw or join from this point to this point, so this, and this will again obey triangle law. So R2 would be equals to R1 plus C. R1 we have calculated as A plus B. So it will be A plus B plus C. And in last part, let's say this is R3. So it will be resultant of R2 and D. Now, if you put the value of R2 to be this, you will get A, B, C, and D. So we can conclude addition is nothing but binary operation, which means we have to add two terms simultaneously, and then we process or we move further. So polygon law is valid for more than two vectors. So in all that possibility or that case, you have to arrange each vector as consecutive term, then resultant of the whole will define you or will join from the tail of first to the head of final. So arrange all vector as consecutive vector. Then resultant will join from the tail of first to the head of final. Is it clear?
Yes, sir.
Okay, just write it down. Shab, any doubt? Okay.
Done, sir.
Okay. Next is we have to calculate magnitude of these resultant. So next is magnitude of resultant. Let's say this is vector A, this is vector B, and this is a resultant of A and B as R. We have to somehow define magnitude of this resultant. So let's say this A having magnitude resultant R having magnitude A is from this point to this point. I have extended this particular line to this, and B is from this point to this point, and resultant R is from this point to this point. Now, angle between A and B is this term, let's say theta. So A, B, C, and D. Is it clear till this diagram?
Yes, sir.
Okay. Now, if you define in this particular diagram, let's say in triangle ABC, I want to calculate AB and BC, which is nothing but base and perpendicular for this triangle, for this theta. So if you want to calculate cos theta, it will be base over hypotenuse. So BC would be equals to AC times cos theta. AC is B, so you will say B times cos theta as BC. Similarly, if you want to calculate sin theta, it will be perpendicular over hypotenuse. So from this, AB will be equals to B times sin theta. So I have just calculated AB and BC. Now, in triangle ABD, if I have to calculate R, which is nothing but hypotenuse of this whole triangle, for which perpendicular is AB and base is BD. So using Pythagoras theorem, we can say using Pythagoras theorem, we can say AD square is equals to AB square plus BD square. We may write BD as BC plus CD whole square. Now on putting all the values, AD is R, AB is B times sin theta whole square, BC is B times cos theta whole square, plus CD is A whole square. Is it clear?
Yes, sir.
Namun, okay. Now on simplifying it further, it will be B square times sine square theta plus, we have A plus B whole square. So on expanding using the rule, it will be A square plus B square plus 2 times AB. Now in this part, if you take out common from both these two terms as B square, so you will get sine squared plus cos square theta plus a squared 2ab times cos theta. Now sin square theta plus cos square theta is nothing but 1. So you will say it will be b squared plus a squared plus 2ab cos theta is equals to r squared. And last, if you want to calculate just r, move square to the other side, you will get r is equals to root under a squared plus b squared plus 2ab cos theta as your final resultant. Shab, is it clear? Okay, just write it down from this part.
Done, sir.
Shab, done? Now this is your final result of this resultant or magnitude of resultant. Now we may define its value. Let's say at theta is equals to 0 degree. So cos 0 will be maximum as 1. So resultant of this will be a plus b as maximum value. Similarly, if theta is equals to 180 degree, cos of 180 degree will be minus 1. So if you put this term in this part, you will get resultant minimum as a minus b. Now, from this, we can conclude resultant of any two vector will lie from r minimum to r maximum. So we can say this will be the range of defining its resultant. So resultant of any two vector will lie from r minimum, that is from a minus b, to r maximum, that is a plus b. Is it clear?
Yes, sir.
I'm giving you some example related to this. Let's say if magnitude of two vector having inclination as 60 degree is 3 unit and 5 unit respectively. Find resultant. Try to solve. Just see in this part, A is 3 unit, B is 5 unit, and theta is 60 degree. Put these values in this formula and simplify it. You'll say A is equals to 3, B is equals to 5, and theta is equals to 60 degree. Try to find a resultant. Namuna, any proud? Good. Shab? Any problem while solving? Just put all the values in the above formula and simplify it. R is equals to A square B square 2AB times cos theta root under. A is given as 3, so 3 square. B is 5, so it will be 5 square. 2 times first term, that is 3. Second term, that is 5. And cos of 60 degree will be half root under. So it will be 9 plus 25 plus 2 and 2 will cancel out. So you will get 15 root under 15 plus 25, 40 plus 9, 49 root under. So it will be 7. Schwab, is it clear? Okay. If A is equals to B is equals to R, then find theta. It means magnitude of first vector, second vector, and resultant vector. If all are equal, then what would be the inclination between them? Just put all the values in above formula. R is equals to A square plus B square plus 2AB cos theta root under. Put all term to be equal, or let's say all to be x, and simplify it. Try to solve. Put all to be just x. And take squaring both sides and simplify it. Maimuna, any doubt? Just check your calculation. Put the value of r to be x. So it will be x squared 2 times x squared cos theta root 100. On squaring both sides, it will become x squared is equals to 2x squared cos theta. Move this term to the other side, it will be x squared minus 2x squared is equals to 2x squared cos theta. So on subtracting these two terms, you will get minus of x squared 2 times of x squared cos theta. Move this term to the other side, you will get x squared divided by 2x squared is equals to cos theta, or cos theta is equals to minus 1 by 2. If cos theta is equals to this term, which is in negative, it means it must be in second quadrant. So theta will be equals to 60 degree for just half, since it have negative value. So just subtract that particular angle from 1 degree. So it will be 120 degree. Is it clear?
Yes, sir.
Shab, is it clear? Wahid, any doubt till this? Okay. Just write it down. Shab, have it done? Wahid? Okay. If two vectors are 14 unit and 8 unit. Then define which will not be its resultant. Try to solve. Just use this concept. For resultant of any two vector, it must lie in between minimum value to maximum value, and try to solve. Any more? Mamuna? Good. Shab? Wahid? Just send me your answer. Just see, I defined you. In this part, we have A is equals to 14 and B is equals to 8. So the resultant would lie from R minimum, that is A minus B. So it will be 14 minus 8, that is 6, to R maximum, that would be A plus B. So it will be 22. It means your resultant would lie between 6 to 22. First is 9, which is in between this term, so it must lie. Second is 5, which is beyond this range, so this will not be possible. Third is 25, which is again beyond this range, so this will also be not possible. And fourth is 15, which will lie in this range, so it will be possible. So option B and C will not be resultant of this particular two term. Is it clear, Shuam? Wahid, is it clear? Good. Now one more term related to this resultant is to define inclination of a resultant with respect to horizontal, or it will maybe termed as direction of resultant. Let's say first vector was along this direction as A, second was along this direction as B, and resultant of these two terms along this direction as R. So inclination of this R with respect to A is beta. We had calculated this particular term as B cos theta from this point to this point, and similarly this term as B sin theta from this point to this point. So this is A, B, C, and D. Now we have to calculate direction of resultant, which means inclination of resultant with respect to A. So it will be tan beta is equals to perpendicular over base. So it will be AB divided by BD. On further simplifying it, you will get CD plus BC. On putting all the values, it will be B sin theta divided by A plus B times cos theta is equals to tan beta. So this is formula to calculate inclination of resultant with respect to first vector. Shrab, is it clear? Have you all done?
Yes, sir.
Wahid, done? Okay. So let's stop here. We'll continue next in our next class. I will define you some of the problem related to this particular resultant. Then we will start splitting or resolving any vector, and then we will start product of any two vector. Okay.
Okay,
So
sir.
try to revise this whole part and try to do more and more problem related to this. We'll meet in next class. Okay.
Okay, sir. Thank you.
Okay. Thank you. Thank you.